So this is a demonstration of Grama, and we're going to use it to study a plate in danger of buckling. You can imagine this plate as being the top surface of a wing with load coming in from either side. What we're going to do is we're going to model the safety, and we're going to model the safety as capacity minus demand. Now, capacity is the ability of the plate to take load, and demand is the amount of load that's placed on the plate. There are two important cases to think about. When safety is greater than 0, it means this plate is safe. It does not buckle. But when safety is less than or equal to 0, it's unsafe. The plate will buckle. Now, capacity and demand both come from an engineering analysis, which is something you would learn through an engineering degree. But for the moment, I've gone ahead and carried out this analysis in a separate file. But I want to give you a sense of what goes into this analysis. We have some set of inputs. Some of those inputs go to computing the capacity, while some of the inputs go to computing demand. Both demand and capacity go in to compute safety, and we get our output. So let's simulate from this model a few thousand times. What this is going to show us is what values our inputs take. What we can see here is that for this input, t, the thickness of the plate, and for h, the height of the plate, there's only one input value. These inputs are not uncertain, they're deterministic. Let's contrast those with E, the elasticity, and mu, the Poisson ratio. What we can see is that these inputs take different values, as evidenced by this histogram. What this means is that there's uncertainty in these inputs. Now, what would happen if we ignore that uncertainty? If we think just about single values, say towards the middle of both of these distributions? Well, let's carry out an analysis ignoring the uncertainty. What we get is a safety value greater than 0, so the conclusion we would draw here is that this plate will not buckle. We would conclude that the plate is safe. However, let's imagine that we didn't ignore the uncertainty. What would we get then? We would get something qualitatively different. We would get this histogram of outputs, and we would see that some small fraction of these are less than 0. These correspond to unsafe buckled cases. And if we look at the lower 1% of this distribution, we get a safety value that's negative. So what we get is a different conclusion. We conclude neither that the plate is safe nor unsafe. We conclude that the plate has some small probability of buckling, which is a qualitatively different understanding